right? So this is how, okay, humans, okay, are just making the decisions. Okay, in the same way, okay, decision tree is also making the decisions, right? Decision tree is also making the decision. Understood, guys? And here, okay, these are the few terms. Okay, this is going to be the root node. Okay, these are just the nodes. Okay, this thing, these are just the nodes, you know, I can say these are, okay, you will see these are just the, leaf node, right? So these few criterias are there. Okay, we will have to understand these terms. Okay, what does this mean and what does this mean? Okay, so that is the thing. Okay, so that is the decision tree in short. Okay, so what we can do is we can now simply take a simple data, right, and implement the decision tree on it, right? And one more thing, guys, the data again is pre-processed. Okay, because if we go with the, again, the for each and every data set, if we go with the pre-processing steps, then it will be, very time consuming process, right? And as you know, we have the some limited amount of time. So that's why let us go and use the pre-processed data and implement the decision tree algorithm, right? It's very, it's very cool algorithm. Okay, now again, as we know, guys, what are the different libraries we wanna import? Let's say we created the new notebook, so that's why we'll have to import the again the libraries. So that's why what we can do is we can use the same libraries over here. But now, okay, now we can simply, you know change this linear model to our decision tree model. Okay, right? We just wanted to change this thing. Okay, so there are few things which are there. Okay, we can do this thing. Okay, we can simply go with the tree method is there, and in the tree method you will find that, okay, let me remove this and just use the, you know tab. And in the tab you will find that, okay, there are multiple, you know algorithms are there, like base decision tree is there, decision tree classifier is there, tree regression is there, then export graph is, this is the visualization of decision tree, right? Export text is there. Okay, you can export the, decision trees of all the fundamentals, like how the decision tree you can create that kind of text, you can export it. Okay, then extra decision tree classifier is there, extra tree regressor is there. Okay, these are the few algorithms are there, means which means just the, variety of algorithms, you can simply say. Okay, this is a classification problem because we are talking about the classification problem, right? So that's why I'm gonna use the decision tree classifier over here. So let's go and enter it. Okay, if you wanted to, solve the regression problem, so you can use the decision tree regressor. Okay, okay, these are the few things. Okay, now in the data set, I just wanted to, as we are coming with the, going forward with the multiple data set. So as we know, okay, each and every data set is different, so we will have to make few changes in our data set, right? We will have to make the few changes in our data set, isn't it? So at that time, okay, these are the, few things we'll have to do. These are the compulsory one. Let's go and run this. Okay, and let's go and read the data. Okay, then at that time, okay, when we are dealing with that particular situation, let's say to split the data, we need again to, import the sklearn dot model selection, import train test split method. So at that time we'll, again use that particular code to import that particular method, right? So let us go ahead quickly and import the our data. Okay, so here I'm gonna use the read the user's data. Okay, as I shared the user data with you, so I know, okay, we will find the user data over here. Yeah, user data dot csv. Okay, and I hope you got the the user data file as well. You downloaded it from the drive, right? If not, try to download it. Okay, now this is my user data. Okay, let's go and run this and let's see the data now. Okay, this is my tf.head. I just wanted to see the top 5 entries of my data, and here you can see the user id, gender is there, age is there, estimated salary is there, and purchase history is there. Okay, now what is my problem over here? I just wanted to create a classification model. Okay, okay, this is the first thing I just wanted to do. Now here you can see that in my data you will find that the user id is there. Okay, now user id is just the is just the the nominal scale data, just the label. Okay, that we wanna uh, you know just the unique label or the unique id, I can say, right? Primary key in sql, right? That is my user id, right? Then I don't want this because this is not helpful for my model building part. So what I can do is I can simply remove it, or I can simply drop this particular thing, right? So instead of dropping, what we can do is, okay, we can taking the few columns which we will be using for our further analysis, right? Then second column is gender. Okay, gender column is there again. Then we have the age, right? Okay, then we have the estimated salary column. So basically these three columns which are important for our analysis, right? These three columns which are important for our analysis. Then we have the purchased history. So basically depends upon my data of the customers. Okay, we will have to identify whether the person purchase my particular product or not. Okay, so this is my target. Okay, this is my target. So I have past data depending upon the age, depending upon the gender and their estimated salary. Okay, I will check whether the customers are preferring to purchase my product or not. Now our main goal is to what is my problem. Okay, I just wanted to build a model of classification. Why I wanted to build a model of classification? Because I just wanted to see whether customer is interested to purchase my product or not. That is my main problem. Okay, I just wanted to check whether the customers are interested to purchase my product or not. Okay, and on the basis of their estimated salary, age, gender, okay, I will check, okay, whether the customer is going to purchase my product or not. So I have the data of few customers, the past data, and the customers which didn't purchase my product as well. So I took the data of those customers as well, because they just visited to my uh, website. Okay, and just I just took the survey, okay, from those customers. Okay, so and in the survey I got these many features: gender, age, estimated salary as well. Okay, as well as we got the lot of things, right? But here you will find that, okay, we took this much only because just to show you how to implement the decision tree. That's the main aim of mine over here in this for this particular session. Now here, okay, in I'm gonna use the age and estimated salary as my independent features. Okay, age and estimated salary, because of the due to the time restrictions, okay, we'll have to go with this two salary, the columns. Okay, because here you will find that the gender column is the again the male and female column, I'll have to add the one hot encoding to change that again and do some pre-processing again. So because of time restriction, okay, we'll go ahead with only age and estimated salary, and we build the model which can predict the purchase history, right? Which can predict that person is able to purchase my item or product or not, right? So for that, I can simply split my data into as a my input data and my output data. So what is my input data? Okay, df dot ilock. As we know, we use this method in the previous sessions as well. Okay, all the rows I want, but in the in the X only, I want age and estimated salary. So I'll use the age and estimated salaries index number over here. Okay, so I'll add the index number like this, the 2, because here index number start with 0, then 1, and for age index number is 2, and for estimated salary index number is 3. So what I'll do is I'll add the index number as the 3, right? So I mentioned this 2 and 3 in the list. That's why, okay, I'm able to get the output, okay, as the age and estimated salary. Okay, if I'm using this like this, okay, 2 and 3, then you will get only 2 column, not the 3. But now understand, I will be using the 2 and 3 in the list. Okay, in the list, then we will be getting the values. Okay, so I want the values now, so what I can do is dot values. Okay, I want the values only, not the name and all. Okay, second thing is that I wanted to extract the target from my data. Again, I'm gonna use the ilog method. Okay, I'll use the square brackets. I want the all the rows of my target column, and I want the my target column which is of the index 4, right? That's it. Dot values, I just want the values, nothing else. I don't want the column name and all, right? So these are my, this is my data. Yeah, now after this, after getting the data X and Y, okay, here what I can do is I just wanted to split that data into training and testing. Okay, and why I just wanted to split that data into the training and testing? Because I will build the model on the training data, and I will make the prediction on the test data. So, okay, which means that I I will be checking my model is comfortable with the new data or not, right? So, let us do that. Then you will understand this thing. sklearn, okay, dot model selection, okay, import train. Here you will find that the train test split. So many things are there, guys. Huh? Okay, train test split. Now here you will find that I'll have to add the the data sets which I wanted to create from this. Okay, so how many data set I just wanted to create? I just wanted to create the data for the X train, right? I just wanted to create the data from X test, right? And remember, guys, the order for this data set is very much important. Huh? Okay, if you miss the order, you will get the wrong results. Okay, Y train and Y test. The order is very much important. Train test split, just add the X data, just add the Y data, and I just wanted to take the my training data as a 70% of my overall data. Okay, so that's why I'm gonna make the set the size for the test data is going to be the 30%. So 30%, which means 0.3, right? 0.3. And basically this is going to be the splitting, but in the form, okay, in a random way. Okay, as we know, we understood what is the simple random sampling is. So in the simple random sampling, which means we are taking a samples randomly from the data. So here we are doing the same thing. Okay, we are taking the samples. First we are taking the 70%, okay, random variables, random values from my original data, right? And we are taking the 30% of my data which is totally taken by random in my test data. Okay, so 30% as my test data and 70% as my trained data, right? So, and last step is going to be the random state is there. Why? Because after doing this, I don't wanna see any changes in my accuracy. Okay, because let's say if you are working in a team, you want the the same accuracy each and every time. So then you can use the any constant value as the parameter, ra- pa, parameter random state, and that particular constant value in your team, which means your all the teams are using a random state equal to 10. Okay, then all of you will get the same results. Okay, this is the thing. Now let's go and run this. Okay, now, okay, let me show you the the size for this train dot the size for this is going to be the you know 280. Okay, now what I can do is I can simply print the user data size dot shape. So I'll get the shape of my original data, then print of my extend data. Okay, then I can simply copy this thing. Okay, now here what I can do is I can simply copy the x train, then y train, then x test, you know and then y test. Okay, let me run this. Okay, user data is not defined. Okay, not user data, it's df. Okay, so yeah, so see, I'm doing this in front of you, so sometimes error will be might be there. So you will find that, okay, you will have to, okay, if you know how to read the error, then you will definitely you know able to read the error and you can solve that particular error, right? So here you go. Yeah, y test. So here you can see that, guys. Okay, initially we got the data how much, 400 variables are 400 observations are there and only 5 columns are there. Okay, out of which, okay, 4 columns are nothing but my input column and 1 column is my target column. Now here you can see that, okay, I took only 2 column as my independent data, x data, right? In my x data you will find that only two columns, and in my test data you will find that in my target data you will find that only 1 column. That's why you will see that only the rows, not the column. you know Understood? So this is the thing. Now we can do it. Okay, we can simply, here you can see that the second thing, okay, what we can do is, okay, now if you see the, let's say, okay, if you see the train data, so you will see that the range, okay, range of your first column, okay, the age column, 49, 47, 50 is there, and the range of the estimated salary is very big. It's a 5-digit number, or sometimes might be 6-digit number you will get. Okay, so as compared to 2-digit number, okay, this is the 6-digit or 5-digit number. So when you are building the model, so at that time this column will dominate, right? Yes. So at the time of building the model, okay, this column will dominate, this column will have the highest weightage, right? And this column has the lowest weightage. So I don't want this kind of scenario. I want these 2 columns will be on a same weightage. So that's why what I can do is I can simply convert this data, okay, into a I can do a data transformation. Okay, so I can transform simply the range of both the data. So that's why we have the few data transformation technique. So in the that is nothing but a feature scaling. That is nothing but a feature scaling, right? So here what we will be doing is feature scaling, okay, to change the transform the range of both the data, right? And then you know again for that what we want pre-processing pre-processing from sklearn dot pre-processing import the one thing which is nothing but the standard scalar, right? We want the standard scalar, right? So this is nothing but a okay, this is the one method. With the help of that you can transform this data into, yeah, and you can convert this into the same range, right? So that is the thing. So let's say, okay, so standard scalar you can do. uh, so I'll be creating this, okay. I'm gonna use this. Let me copy this quickly, okay. Okay, and after this I'm gonna use this or apply this on my train data, because you will find that we will be building the model on X train data, right? And then we will be implementing on the you know the test data. So that's why we will have to transform this data. So this data is the X data na? So X train as well as X train, okay. So we will be transforming our both the data, the X train and the X test as well, right? So first let's go and transform the X train data, right? So we will be implementing stx dot fit underscore transform, right? Transform, right? So here simply add your train data, okay, and here copy this thing, okay, and put it over here, and simply change the data X test, right? And enter this. And now let me show you the data. Now are you able to see we just change the data, we transform the data in the same range. Now the range for this is going to be the the range of standard normal distribution minus 32 plus 3. You will see that the your 99.997, 6 times 9 means around all the data, 100% of your data we just transform into the range minus 32 plus 3. Okay, so here you will see that the your initial data is this, and you just transform the data like this. So now, okay, my data is ready. So now let's go and build the model. Okay, so as we know, we created the model, we imported the model already. So my decision tree model is this, okay, decision tree. Now in short, let's go with the model name, okay. And as we know, the name of our model is going to be the decision tree classifier, right? Right, so this is my model's name, okay. Now what I can do is I can simply use this model to fit on my data, right? That we did in the logistic regression as well, right? So this is the thing, okay. So here you can see that now we are using the extend, okay, data to make the model which can predict my y column. So we will be using this x and y data of the train for building the model first. So let's go and run this, right? So here you will see that I'm gonna run now, okay, run this. Now here you can see that fit missing one argument positional, why no, this is the method, this is not the attribute, right? Yeah, yeah, this is the method, this is not the attribute. Yeah, done with the the thing. Yeah, now, okay, what we can do is after building the model, our aim is to go for the prediction one, right? So we can simply go for the prediction one. Here you can see that we are just making the predictions now. you know the we are using the model dot pred, okay, model dot predict, and here we are simply implementing our x train data, and we will be getting our predicted values. So we can use that predicted values to build the confusion matrix, right? Okay, we just going to build the confusion matrix, and in the confusion matrix we are using the y train, my target column, actual target column, and my predicted target column, y train predict, right? And let me go and see. So this is the first thing. Now what will be the second thing? Simply copy this, okay, and transform this at the classification report, okay, and make the use the print function, right? And let's run it. And here you can see that we got the output, and you know that how to rate the accuracy, precision, recall, F1 score, support. I told you already. Now this is for the train, okay? So you can do the same thing for the test as well, because we created the model, huh? So you can do the same thing for the test. So let me quickly show you, and then we will stop, guys. Now here, let us use the test, okay? We are going to make the prediction of the new day for the new data set. Okay, test is not okay, test is my new data set. See, okay, we created the model, we build the model on the train data. You see that the train data we took, okay, we didn't touch the test data, right? We didn't touch the test data. Now we are using the test data to make the prediction of my, let's say, my model now using or handling the new data now, right? So that's why I'm gonna show you the results for this, okay? So let me change this to train to test, and let me go and run this, then you will understand. Okay, here you can see. Okay, now initially my model is able to make the predictions, okay, 100% of the time correctly on the train data. But when it comes to new data, okay, new data that my model don't know about it, so at that time my model is able to get the accuracy only 85%. So you see the some kind of drop over here, some kind of drop over here. So you will find that for the new data set, for making the prediction about the new data set, you will find that some kind of less accuracy. Okay, so guys, that is it, how we can build the model and how we can check the model's credibility. Okay, credibility. So here you can see that the 85% accuracy is that for the for the prediction of new data set. Okay, so guys, that is it about the today's session. Thank you guys, thank you very much.